Dear students, Assalamu alaikum. It is week number 7 and we are having the second half of the chapter number 6, Work, Energy and Power. And I will explain the topics of this week one by one in the coming slides. The content of this week are major sources of energy, mass energy equation, energy and environment, energy converters mean energy converting devices, efficiency and power. I will explain all these topics in the next slides. The objective of this week are students will be able to explain major sources of energy, understand mass energy relation, comprehend the concept of efficiency and power. The first topic is major sources of energy. The number one is the fossil fuels. Fossil fuels are the combinations of hydrogen and carbon. That's why these are called hydrocarbons. We use fossil fuels such as coal, oil and gas to heat our houses and run industry and transport. They are usually hydrocarbons, mean compounds of carbon and hydrogen. When these are burnt, they combine with the oxygen from the air. The carbon becomes carbon dioxide and hydrogen becomes hydrogen oxide called water. And energy is released as a heat. I have given the relation as carbon plus hydrogen gives us carbon dioxide plus heat energy, and hydrocarbons plus oxygen gives us carbon dioxide plus water plus heat energy. Students, these fossil fuels are called non-renewable energy sources because these fossil fuels took millions of years for their formation, and we are using these fossil fuels at a very fast rate. And if we keep on increasing these fossil fuels at this rate, these will soon be exhausted and will not be able to be replenished in short time. And fossil fuels will also not be able to meet our future energy needs. This would cause serious social and economic problems. So we must use them wisely and at the same time develop new energy sources to our future survival. These fossil fuels also produce environmental problems. These fossil fuels produce carbon monoxide and other harmful gases which pollute the environment, and these are also called fatal health problems like headache, tension, nausea, allergic reactions of eyes, nose and throat, and long exposure of these harmful gases may cause asthma, lungs cancer, heart diseases and even damage to brain, nerve and other organs of our body. And number two is nuclear fuels. Students, nuclear power plants, we get energy as a result of fission reaction. During this fission reaction, heavy atoms such as uranium atom splits up into smaller parts, releasing a large amount of energy. Nuclear power plants give out a lot of nuclear radiation and vast amount of heat. A part of this heat is used to run power plants, and a large part of heat goes waste into the environment. And also, nuclear power plants also create radioactive waste, which is a big problem today, how to be dumped safely. Number 3 is renewable energy sources. The first one is energy from water. And students, what energy from the water is a very cheap source. Dams are being constructed at suitable locations in different parts of the world. Dams serve many purposes. They help to control floods by storing water. The stored water in the dams is also used for irrigation and also to generate electrical energy without creating much environmental problems. And number 2 is energy from the sun. Solar energy is energy coming from the sun and is used directly and indirectly. Sunlight does not pollute the environment in any way. Sun rays are the ultimate source of the life on the earth, and we are dependent on the sun for all our food and fuels. If we find a suitable method to use a small fraction of the solar energy that is reaching the earth, then it would be enough to fulfill our energy requirements. Next is the wind energy. Students, wind has been used as a source of energy for centuries. It has powered sailing ships, across the oceans. It has been used by windmills to grind grain and pump water. More recently, wind power is used. Most recently, wind power is used to turn wind turbines. When many wind machines are grouped together on wind farms, they can generate enough power to operate power plants. In the United States, some wind farms generate more than 1300 megawatt of electricity a day. In Europe, many wind farms routinely generate 100 megawatts of or more electricity a day. Next is geothermal energy. Students, in some parts of the world, the earth provides us hot water from geysers and hot springs. There is a hot molten part deep in the earth called magma. Water reaching close to the magma changes to steam, and due to high temperature of magma, this energy is called geothermal energy. And the next is energy from the biomass. Biomass is plant or animal waste that can be burnt as fuel. Other forms of biomass are garbage, farm waste, sugarcane, and other plants. These wastes are used to run power plants. Many industries that use forest products get half of their electricity by burning bark and other wood waste. Biomass can serve as another energy source, but problems are there in its use. When animal dung, dead plants, and dead animal decompose, they give off a mixture of methane and carbon dioxide. Electricity can be generated by burning methane. And now I will discuss the solar heating system. It is the part of solar energy. Students, solar heating system, it consists of three parts. One is the collector. It consists of a panel which gets the solar heat, and this solar heat is trapped in this part. The second is the storage device. It is the water storage device which is to be heated. And a distribution system, it consists of a system which distributes the hot water to the whole house. Look at this picture. It is properly labeled. Here it is written sun rays. This is the collector part, and it consists of a glass panel. It is made of glass panels over blank metal plates. The plates absorb the sun's energy, which heats a liquid flowing in the pipe at the back of the collector. The hot water can be used for cooking, washing, and heating the buildings. Solar energy is used in solar cookers, solar distillation plants, solar power plants, etc. And you have seen that in the diagram. After the collector is the aluminium foil, and this you know that aluminium is a good absorber of the heat, and we are having copper tubing. The copper is also good absorber of the heat. Water is running through the copper tubes, and this water becomes hot, and hot water is rises up to the storage tank, and cold water takes the place of the hot water. Next is solar cells or photocells. Students, solar energy can also be converted directly into electricity by solar cells. A solar cell, also called photocell, is made from silicon wafer. When sunlight falls on a solar cell, it converts the light directly into electrical energy. Solar cells are used in calculators, watches, and toys. And large number of solar cells are wired together to form solar panels. Solar panels can provide power to telephone booths, lighthouses, and scientific research centers. Solar panels are also used to power satellites. And several other methods to trap sun rays are underway. If scientists could find an efficient and inexpensive method to use solar energy, then the people will be able to get unlimited energy as long as sun continues to shine. Next is the famous mass energy equation of the Einstein. The students, these equations given by the Einstein gives the relation between the mass and the energy. Einstein predicted that matter can be converted into energy, and according to him, a loss in the mass of a body provides a lot of energy. This happens in nuclear reactions. The relation between mass m and energy E is given by Einstein's mass energy equation. E is equal to mc square. Here E stands for energy, m is the mass, and c is the speed of light in vacuum or air. It is a constant value. C is equal to 3 × 10⁸ meter per second. This equation shows that a large amount of energy is obtained from a small fraction of mass. So we can say that matter is a highly considered form of energy. The process of getting energy from our nuclear power plants is based on this equation. The process has taken place on the sun and the stars for the last million of years. Only a very small fraction of the sun's energy reaches the earth. This very small fraction of the sun's energy is responsible for life on the earth. Now, electricity from fossil fuels. Students, I have given this block diagram, but I will explain this block diagram first, then I will discuss this diagram. Students, we are using electricity in houses, offices, schools, businesses, factories, and in farms. We have different ways of generating electricity. Most of the electricity is obtained using fossil fuels such as oil, gas, and coal. Fossil fuels are burnt in thermal power stations to produce electricity. These are called thermal power stations, and various energy conversions process involved in producing electricity from coal are described in this block diagram. Number 1. Chemical energy stored in the fossil fuel is used as the input, and when this fossil fuel is burnt, heat energy is used to produce high pressure steam in a boiler. And the potential energy of this steam is used to turn a turbine, and mechanical energy from turbine is used to run an electric generator, and last, electricity output from an electric generator. So students, first of all, burning process took place and energy changing from potential into mechanical energy, and then transferring mechanical energy, and last mechanical energy into electrical energy is converted. Next is the flow diagram for energy converters. Students, I have given 3 energy converters. These are also called the transducers, which converts energy from one form to the another. First one is the electric lamp. Second is the vehicle running with the constant speed on a level road. Constant speed means there is no increase in the kinetic energy of the car. It has constant speed is fixed, so there is no increase in speed, so no increase in the kinetic energy as well. And the last is the power station. And in the next slide, I have given the diagram, and I will discuss these 3 energy converters one by one. Number 1, electric lamp. At the top, the blue rectangle shows the electrical energy. An incandescent lamp uses electrical energy. It is the input energy, and this lamp converts this electrical energy into light energy and into heat energy. And the second is the vehicle running with the constant speed on a level road. In the car, fuel in a car is the source of chemical energy. It is the input form of energy, and car engine produces heat energy, kinetic energy, and sound energy, the noise definitely, and the last, the kinetic energy is converted into useful work done, and the third one last, the power station. Students, in power station, potential energy of stored water is used as an input, and this potential energy is then converted into kinetic energy of the flowing water, and this kinetic energy is converted into heat energy due to friction. It is also form of an output, and this kinetic energy is also converted into sound energy as a noise, and the same kinetic energy is converted into useful work done in running the turbine. And last, the kinetic energy of the turbine is converted into electrical energy from electric generator, and this is the useful output form. And students, these power stations are not very efficient. They just convert a small fraction, small part of the energy of the water into electrical energy. Now, what is efficiency? As just I described in the previous slide that the power stations are not much efficient. They use a small energy of the input energy into output, useful output. Now I will discuss what is efficiency. Students, we always compare different machines by describing how efficient they are, and we always select the most efficient machine. What is efficiency? We give some form of energy to machines as input to get useful work done by them as output. For example, electric motors may be used to pump water, to blow the air, to wash clothes, to drill the holes, etc. For that they use electrical energy. How good a machine is? It depends on how much output we obtain from it by giving certain input. The ratio of useful output to input energy is very important to judge the working of a machine. It is called the efficiency of a machine, and it is defined as efficiency of a system is the ratio of the required form of energy obtained from a system as output to the total energy given to it as input. I have given the equation as well. Efficiency is equal to required form of output over total input energy, and we can show this efficiency as a percentage by just multiplying this equation by 100, and we get the efficiency in percentage form. This efficiency has no unit because it is the ratio between two same quantities. Mean output energy over input energy. Energy has the same unit, joule over joule, it will be cancelled. So efficiency has no unit. And the last topic is the power. Students, the power is the rate of doing work. Now I will explain what is meant by the rate of doing work. For example, two persons have done equal work. One person took 1 hour to complete, and the other person completed the same job in 5 hours. No doubt, both of them have done equal work, but their rate of doing work is different. First person completed the same job in 1 hour, second person completed the same job in 5 hours. So which one is more efficient? Definitely the first person who has completed the task in lesser time. So students, efficiency is not the only the name of doing work, it is the rate of doing work. If a machine completes the work in lesser time, so it is more powerful. So mathematically, power is equal to work done over time taken, or W over T. And students, keep in mind, power is a scalar quantity and its SI unit is watt. And also I have given the other units of power as well, larger units as well, and I have defined 1 watt power as well. We can define 1 watt power as if a body does a work at the rate of 1 joule per second, or I can say that if a body is doing 1 joule work in 1 second, then the power of that body will be 1 watt, or we can say 1 joule per 1 second is equal to 1 watt. The larger units are 1 kilowatt is equal to 1000 watt, and 1 megawatt is equal to 1000 watt, or 10 to the power 6 watt. And students, another unit of power is horsepower. It is imperial unit. It is equal to 746 watts. Now students, I will give the recap of the whole topics of this week. Number 1, students, we discussed major sources of energy. It included fossil fuels and energy from nuclear fuels, and also we discussed the renewable energy sources. It was energy from the water, energy from the sun, and also the wind energy, geothermal energy, and energy from the biomass. I explained all these topics in the previous slides. We also discussed solar house heating system, and I discussed the parts of the solar heating system. It had 3 parts: a collector, storage, number 2 storage device, number 3 distribution system. And we also discussed solar cells, how solar cells convert the energy of the sunlight into electrical energy. And we discussed mass energy equation. This equations gave us the relation between mass and energy, and we discussed that matter is a constituted form of energy, mean matter can be converted into energy. And next we discussed electricity from fossil fuels. We discussed the block diagram, how different forms of energies are converted finally into electrical energy. And next was the flow diagrams of an energy converter. We discussed the electric lamp, how electric lamp converts electrical energy into light energy and heat energy. Then we discussed the vehicle running on the road with a constant speed, and how chemical energy of the fuel is converted into heat energy, sound energy, and kinetic energy, or the energy of the motion. And the last we discussed power station, how power station, which hydropower station, uses the potential energy of the stored water to convert it into kinetic energy, heat energy, sound energy, and that kinetic energy converted into the mechanical energy of the turbine, and that mechanical energy of the turbine is converted in finally into electricity. And next we discuss the efficiency, and efficiency we discuss that is the ratio of the useful output to total input energy, and efficiency has no unit. We also discuss percentage efficiency. Just we multiply the required form of output to total input energy multiplied by 100. And the last topic was power, and power was the rate of doing work, and we discussed the formula. Power is equal to work over time, and its unit was watt, and I defined the watt. 1 watt is equal to the work done at the rate of 1 joule per 1 second, and we also discussed the unit of power as horsepower, which is equal to 746 watt. So students, hopefully this will be very useful for you. I have given the assignment at the end of this topic, and you will be able to easily solve that assignments. Good luck students. Allah Hafiz.